Welcome protein coders, let's build some coding muscles. Today we're gonna see Hamiltonian path. What is an Hamiltonian path? It is similar to the Euler's path which we have studied, but here just a slight modification. It is a path in a graph where each node is visited exactly once and all edges are visited at most once. That maybe one edge can be not visited, but it should not be visited more than once. Let's see in the graph 1. Let's say I start traversal from here, and if I move like this, and you see I have visited all the nodes, right, exactly once, and the edges also at most once. So this is an Hamiltonian path. And if I can visit the starting node via Hamiltonian path, then I would say this is an Hamiltonian cycle. Okay, now let's see in the graph 2. Whichever way I will try, let's see this way. So see, I have visited this edge twice, so this is not an Hamiltonian path. Similarly via this way, so whatever way I would try, I can't get a Hamiltonian path in it. Okay, neither the Hamiltonian cycle. Let's see this in more detail. If you look into this graph, let's start our DFS from the bottom node. You see, via this path I need to visit this edge twice, so this is not an Hamiltonian path. But if I start from this edge, this node, then I can visit all the nodes exactly once and all the edges also at most once. So this is an Hamiltonian path. So that means we have to check all the possibilities, like we have to call DFS for every node and check, right? Unfortunately, we have to perform the DFS and do the brute force way for the Hamiltonian path. So let's articulate the points which we're gonna do in our algorithm. First thing is we will keep a integer count which will track the number of nodes in our path. Then we will call the DFS for each node and check. Okay, and if suppose we didn't find our path, okay, then what we will do, we will backtrack from there. Let's see this in the code, you will understand better. So we have our function, we have our node, integer count, our adjacency list, and visited vector and size of the adjacency list or number of nodes. First thing which we'll do is we'll mark our node visited, right? First thing which we do in our DFS, and we will increase the counter. Okay, then we check if the count is equals to the number of nodes. That means we have traversed all the nodes, we will return true, or else we will traverse the neighboring nodes. Okay, now we will check if the neighboring node is not visited, we will call DFS for it. Okay, and if at any point our DFS also returns true, then we will return true, or else at the end if we don't found the Hamiltonian path, we will just backtrack. We will mark the visited of node false, decrease the count and return false at the end. So that's it guys, that's simple DFS, you can say recursion code for this. Let's see what we have done again. Mark the node visited, increase the count, and check if the count is equals to 1, we will return true, or else we will traverse the neighbors. If the neighboring node is not visited, then we will call DFS for it. If DFS returns true, we will return, and then we will backtrack. And in case of Hamiltonian cycle, we just modify the count check condition. If the count is equals to n, we have to check if any of its neighbor is starting node or not. If the neighboring node is equals to start, and we will pass the starting node also in our DFS. Okay, then we will return true. The DFS also we have to pass the starting node, or else we will return from here. Okay, we will mark visited of node is equals to false, we will backtrack and return false. So this part of the code will change in case of Hamiltonian cycle. Okay guys, let's revise what we have studied. In Hamiltonian path, we need to visit every node once and every edge at most once. And then we explored all the paths, all the possible ways via recursion. And if we don't found any Hamiltonian path, we will backtrack from there, right? In the case of Hamiltonian cycle, we just need to modify this part of the code which we saw, right? So That's all from my side, guys. If you have any questions, please mention them into the comment box. You will find the problem and the solution link into the description box. I hope it was helpful. Keep practicing, keep smiling. Thank you.